So here in 3.2 we take a look at graphing linear equations. So some of the things that we want to notice in graphing linear equation is that we're graphing linear equations in two variables. The variables are to the first power, and the graph produces a straight line, so your line could look like any one of these here. When you graph. So the way that we graph a linear equation is we want to find at least 3 ordered pairs. Once we find those ordered pairs, we can plot the points on a graph and then connect those points. So when we take a look at example 1, where we're given an equation of 3x minus 1 is equal to 2y plus 5. We want to find 3 ordered pairs according to the instructions here. And the way we do that is we pick numbers to represent x or y and then solve for the other variable. So what we can do is we can make a table out of x, y. So here, we have this table. And look, we started out by choosing 0 for x and then substituting it back into the equation, down below. So when we let 0 equal x into the equation, we can see that 3 times 0 will become 0. So that eliminates itself. Leaves us with negative 1 plus 2y plus 5. Negative 1 is equal to 2y plus 5. So we can take this and just rewrite it by letting 2y plus 5 equal negative 1. So we haven't changed the equation, we just switched it around to get our y to the left side. So again, we just wrote 2y plus 5 is equal to negative 1. So same equation, just have our y on our left side of our equal sign now, and then we can start to solve for y by subtracting y on both sides. And that's going to tell us that 2y is equal to 6 at that point. So here 2y is equal to 6 at that point. We divide off the 2 on both sides of the equation so that it cancels, or 2 goes into 2, leaving us with just y. So y is equal to negative 3 at that point. And then we can make our point here. We started out with letting x equal 0, comma, we found out that y was equal to negative 3. So that's one point that we can use to plot to graph. Now what we want to try to do is avoid having fractions. So here we looked at substituting in 1, but when we substituted in 1 for x, we found that y was equal to 3/2. So, we want to avoid, having fractions. So, we probably wouldn't want to use that as one of our points because we will have to plot that point in terms of a fraction for y. So we went and tried to let y equal 0. Started that by letting y equal 0. So that is over here. When we let y equal 0 in the original equation, we're left with just 5 on that side because 2 times 0 is 0. And we get the equation of 3x minus 1 is equal to 5. So we want to get rid of that minus 1 by doing plus 1 on both sides of the equation. When we do that, we eliminate the 1 from over here, and we're left with just 3x is equal to 6. And then we wanted to divide the 3 off of the x to solve for x. So that tells us that x is equal to 2. And then again, we chose to let y equal 0, and we found out that x was equal to 2. So we have another point with whole numbers that we can use to plot the points. Then we went on to try letting x equal 6. So when we let x equal 6, we substitute that back into the original equation here, and we have 3 times 6 gives us 18, so we have 18 minus 1 is equal to 2y plus 5. We simplify the 18 minus 1 to get 17 is equal to 2y plus 5. And then we go on to rewrite it to have our y term on the left side just by writing 2y plus 5 is equal to 17. So it's exactly the same thing. We now just have our y term on the left side of the equal. At that point, we can subtract 5 to isolate the y term. So subtracting 5 on both sides of the equal, leaving us with 2y is equal to 12. Then dividing off your 2 to solve it for y. And at this point we find that y is equal to 6. When y is equal to 6, we write this as we originally selected 6 that we wanted to substitute into the equation for x, and we found out that y also equals 6. So we have 6 comma 6 there. And we can take these points, the 3 points that we found, and the ones that don't involve the fractions, and we can plot the graph. So the first one, 0 comma 3. X is 0 and y is negative 3. So that point there. So x is 0 at that point and y is negative 3. The next point we plot, 2 is x comma 0, y 0, 2 comma 0. So we go to 2 on our x and 0 for our y, and it is that point right there. And then plotting the last point, 6 comma 6. 6, go to 6 at x and move up to 6 for y. And that is going to be about that point somewhere up there. And then we connect those points, producing the line that we see here. Whenever we have a point directly on our axis, let's see, on our x-axis, we have a point directly on that. So that is considered to be our x-intercept at that point. So this point here. And then on our y-axis, we also have a point there. On our y-axis, we have that point. So y that is considered our y-intercept. So our x-intercept is where points fall on our x-axis, and our y-intercept is where points fall on our y-axis. So one thing that we can say about this here is that to find your y-intercept, x is always 0 at your y-intercept. At your x-intercept, y is always 0. So that brings us to graphing with the intercept method. And when we want to graph using the intercept method, we find our y-intercept by letting x equal 0. And then we find our x-intercept by letting y equal 0. And the equation, that is. So to look at an example 1, there we have used the intercept method to graph. So we have the equation of negative 2x plus y is equal to 4. And we want to use that equation to graph it. We want to graph that equation using the intercept method. We find our y-intercept. Again, we find our y-intercept by letting x equal 0 in that equation. So once we substitute 0 in the place of x, we're left with y is equal to 4. So our point is 0, 4. And that is one point we can use to plot on a graph after we find our x-intercept. So to find our x-intercept, we let y equal 0 in the equation. So in the same equation, we go and we substitute 0 in the place of y. That leaves us with just 2x is equal, negative 2x is equal to 4. We divide off the negative 2. So that way we can solve it for x. So x is now going to be equal to negative 2. So in terms of x comma y, for our intercept point, we have negative 2 comma 0, we can take these 2 points that we found and plot them on a graph. So 0, 4 are y-intercept here. And -2, 0 is our x-intercept. And once we plot those points, we connect the line, and we have our graph there. This is our y-intercept and our x-intercept plotted. Also, when we have when we're asked to graph an equation like y is equal to 4, that produces a horizontal line. So we would go to y at 4 and draw a line that's parallel to your x-axis. That is a horizontal line. So whenever we have just the one variable y is equal to something, that's going to produce that horizontal line, which is parallel to your x-axis. Likewise, when we look at graphing x is equal to -3, we go to our x-axis and we draw a vertical line at x is equal to -3, or whatever it is equal to. Again, that produces x. When we only have that one variable, x is equal to something, that's going to produce a vertical line at that point.